Alrighty, wonderful. So hopefully by now you're able to complete problems number 1 through 3 on worksheet 6.1A. If you take a look now into numbers 4 through 11, the directions read, use the parent graph f of x given, sketch each transformation, and list the domain and range with interval notation. Here's the first thing that I want you to do. We learned in the very beginning of the lesson that the parent function is y equals x squared, or f of x equals x squared. The one in your workbook, however, is not the graph y equals x squared, so we're going to change that real quick. So go ahead and with a different colored pen or pencil or marker or whatever you need to do, a sticky note to cover it up, cover up the current graph that they have. Okay, I've covered up the current graph that was already on there, and I'm going to make sure that on my graph I put the actual parent function, y equals x squared. So do that now. We're graphing the parent function y equals x squared over the graph because the original function in the workbook is incorrect. Y equals x squared starts at 0, 0. Okay, its vertex is at 0, 0. The next point, if you remember the pattern, goes over 1, up 1. Okay, and the next one goes over 1, up 1, 2, 3. Okay, so over 1, up 1. Over 1, up 3. Those are the 2 points, 1, 1, and 2, 4 from the very beginning. The same thing happens if I go to the left. Go to the left 1 and up 1. And go to the left 1 and up 1, 2, 3. Those are the points negative 1, 1, and negative 2, 4. Draw in that parent function now. Okay. Wunderbar. Wonderful. What you see on there is the parent function graph, f of x equals x squared. You'll notice that some of these transformations look familiar to you. Okay, we just graphed transformations of the parent function, absolute value of x. We learned a few different things. We learned that stuff inside of the parentheses moves the graph to the right or the left. If it's on the inside, it's opposite. So it says plus a number, it moves it to the left. It says minus a number, it moves it to the right. Okay? Numbers on the outside of the parentheses, the plus or minus at the end of the function. Okay, those are up and down movements, and those are normal. So f of x plus 3 moves a function up 3, and f of x minus 3 moves a function down 3. And then this one, this number 4 right here at the very beginning, says what if we get negative f of x? Negative f of x. Well, the negative is an output change. Okay, since it's on the outside of the f of x, that must be an output change. I know that that must affect my y values. So all my values of y that used to be positive, up here, they used to outcome positive, are now outcoming negative. So same x's, but now negative y's. So let's graph what that looks like. 0, 0 is going to stay where it's at. 0, 0, the vertex is still 0, 0. Okay? And what used to be the point 1, 1, what used to be at 1, 1 is now going to be at 1, negative 1 because my outputs are becoming negative. So what used to be 1, 1 is now 1, negative 1. What used to be at 2, 4, 2, positive 4 is now at 2, negative 4. Okay, what used to be at negative 1, 1 is now at negative 1, negative 1. And negative 2, 4 is now negative 2, negative 4. Hopefully you're able to see now the pattern of the graph. It looks like the same parabola. The same parabola, and it's now downward facing. Okay? And now get this pattern, start to notice it, that if you have a negative outside of the parabola most positive ones, or all positive parabolas, are straight faced upward. The negative out front is going to cause that parabola to not face upward anymore, but to now be upside down. Okay? Good. Got it. Let's talk about number 5. It's a transformation from the original function again. It's going to transform the original parent function y equals x squared. And this number on the outside here, hopefully you remember from transformations, that takes the original f of x graph. And since it's on the outside, since it's a -4 on the outside, it's an output change. It affects my y values. My y values are up and down values. So it's going to take all of my y's and shift them down 4 places. Numbers on the outside affect up and down movement, and they're normal. So f of x used to be a vertex of 0, 0, is now going to be a new vertex of -4. Sorry, 0, -4. Okay, it's same pattern. Over 1, up 1, left 1, up 1, right 1, up 3, left 1, up 3. Same exact shape as before, and now shifted down 4 places. Same exact shape, same size, same everything, shifted down 4 places because of the -4 on the outside. Okay, the question also says, list the domain and the range with interval notation. Let's talk domain. Domain is the left to right movement. Okay, how far right's the function going to go? How far left is the function going to go? So for my normal, here you go. We're going to start with the parent function. Domain and range of the parent function. Well, these arrows are going up, but they're also going to the right. Okay, and this arrow is going up, but it's also going to the left. If I plug in bigger values of x on the outsides, then that function will continue to go to the right and continue to go to the left. So your domain, left to right movement, is going to be from -infinity to +infinity. Your range is how far up does the graph go and how far down does the graph go. Range is up to down movement. Okay, so you have to ask yourself, how far low does it go? How low does my graph go? And how high does my graph go? So how low does it go? Well, it looks like it's in all these positive values up here, but the lowest value it gets to is y equals 0. That's the lowest value in your range. I'm putting a hard bracket because I actually made the graph equal 0. I plugged in 0, so 0's included in my domain. Range goes from the lowest y value to the highest y value. Well, this graph continues to go upward. Okay, I put arrows on the end to represent its continuous movement upward. So the lowest it'll go is 0. The highest it'll go is +infinity. Your range is 0 to infinity with a hard bracket on the 0. How about your domain and range for number 4? Same graph, now flipped upside down, reflected across the x-axis. Domain, arrows on the end represent it will continue to go downward, but it also will continue to go outward. And this arrow will go down, but it's also going outward. So my domain, again, is -infinity to infinity. And my range, my lowest number to my highest number for y values, how low does it go to how high does it go? Well, both of my arrows point downward, so it must continue to go downward. How low is it going to go? We don't know. It goes all the way to -infinity. How high up does it go? What's your highest y value that will be put out of the function? In this case, it doesn't go any higher than 0. It does actually hit 0. So the highest it goes is 0 with a hard bracket. A range of -infinity to 0. Okay, make sure you list your domain and range for all of the functions, number 4 through 11, with the parent function replaced from the one given. All right, gang, great job on numbers 4 through 11, remembering that the transformations are left to right movement inside of the parentheses and up to down movement on the outside of the parentheses, negatives in front, flip it, or reflect it over the x-axis. Your final question in tonight's homework is number 12, and it's a little funky. It doesn't make really any sense at all. How many roots or x-intercepts do the parabolas? Describe the graphs for each possibility. Okay. Let's reword this. Here's what I want you to think about when you're answering this question. Instead of what it says, ask yourself the question, how many roots or x-intercepts could a parabola have? How many roots or x-intercepts? By the way, those two words, well, three words, but, well, whatever, that's a letter. Roots and x-intercepts are synonymous with one another. They mean the same thing. Okay, when I say roots, I mean the x-intercepts. And when I say x-intercepts, I mean the roots. Okay, so how many roots or x-intercepts could a parabola have? How many roots or x-intercepts could a parabola have? And describe the graphs for each possibility. Draw some pictures. Describe what they look like. Maybe make up some functions. That would be cool too. Okay. That concludes today's 6.1A lesson. Thank you for being awesome and studious students. I will collect the notes and the worksheet for 6.1A, your homework, on Wednesday's class. Remember, tonight you are studying for tomorrow's Unit 5 quiz. Okay, we worked on this Friday in class. So online is the review material. Okay, I filled out my 5D worksheet so that you guys could see my work for that night. And also go over the notes from class. Okay, look at that slide that says these are the things that I should know going into the Unit 5 quiz. Give yourself a self-assessment that says these are the things I should study. These are the things I should pay attention to. Okay, these are the things I don't understand at all and I need to know how to do by Tuesday's class. All right, email if you have any questions. I'm happy to help. So that concludes today's video. Thank you so much for watching, and make sure that you have this parent function worksheet 6.1A where we discuss parabolas completed by Wednesday's class. Good luck and have an awesome rest of your day. Hey there, howdy class, it's good to see you all.